Okay, so hello guys. Here I am again, trying to make another video for your reference for the topic which is optimization problem. So this is our week 10 topic for the pre-finals of basic calculus. So let us proceed with the examples. So one common application of calculus is calculating the minimum or the maximum value of a function. For example, companies often want to minimize production cost of maximize revenue. In manufacturing, it is often desirable to minimize the amount of material used to package a product with a certain volume. In this section or in this discussion, we show how to set up these types of minimization and maximization problems and solve them by using the knowledge of differentiation. So, what was presented here are the possible application of these topics, which is um, stated in the previous statement that we uh, discussed. So, among the steps which was presented last time in the previous video, I modified the overall step in order to introduce this new step, which is probably understandable for your own perspective. So this is, let's have this process or these steps in dealing with maxima and minima problems. So introduce all variables. If applicable, draw a figure and label all the variables. Determine which quantity is to be maximized or minimized for what range of values of the variables. If this can be determined at this time. So write a formula for the quantity to be maximized or minimized in terms of variables. This formula may involve more than one variable. So it is depending on the type of problems. So write any equations relating to the independent variables in the formula from step 3. Use this equation to write the quantity to be maximized or minimized as a function of one variable. So basing on the parameters stated or the conditions stated on the problem, you have to identify the different parameters, label them according to the variable usually represented by x and y in our discussion. Then we have those variables which wherein we are going to have equations wherein we will have only one variable after that one. So identify the domain of consideration for the function in step 4 based on the physical problem to be solved. And then after identifying the domain and the constraints of the problem, let us locate the maximum or the minimum value of the function. Then this step typically involves looking for the critical points and evaluating the function at the endpoints. So this is the step wherein we apply our differentiation techniques, wherein we, after differentiation, we are going to equate this one into 0 in order to find our critical points. And then we have to go back to our problem and find or compare our answer if that fits to the specific question on a specific problem. Now let's apply this strategy to maximize the volume with open top box given a constraint on the amount of materials to be used. But before this type of problem, I have presented the problem which is similar to the previous video before the problem about the box. So we have the problem in the previous video about the riverbank. So the same problem will be presented here and well illustrated in order for you to better understand the problem. So a rectangular garden is to be constructed using a rock wall as one side of the garden and wire fencing for the other three sides. Given the 100 feet of wire fencing, determine the dimensions that would create the garden of maximum area. What is the maximum area? So take note, what was asked in this problem were the following parameters. So we have what was asked is the dimension of the garden and at the same time the maximum area of the garden. So let us inspect this problem and try to perform the operations or these steps we presented earlier. So we have Okay, let x denote the length of the side of the garden perpendicular to the rock wall, and y denote the length of the side parallel to the rock wall. Then the area of the garden will be, so basing on the illustration or the figure here, you have x here and you have y here. So we want to find the maximum possible area subject to the constraint that the total fencing is 100 feet. So from the figure, the total amount of fencing used will be equal to, let us add all the sides or let us find the perimeter. So considering that one side will not be covered with the fencing. So we have x plus y plus x, or simply this is equal to 2x plus y. Therefore, the constraint equation will then be 2x plus y is equal to 100. Solving this equation for y, we will have y is equal to 100 minus 2x. Thus, we can rewrite the area. So substituting the value of y to the original equation of the area. This will be equal to area in terms of x is equal to x multiplied by 100 minus 2x. So simplifying this one, this will be equal to 100x minus 2x squared. So after this one, in order for us to find the maximum and minimum values, we are going to find the critical point of the equation. So maximize this one. So this is equal to, in order to maximize this one, we are going to find the first derivative. So the first derivative of this equation will be equal to 100 minus 4x. Therefore, the only critical point of this one is 100 divided by 4, which is equal to 25. We can conclude that the maximum area must occur when x is equal to 25. So if we are going to look at this derivative we have, if we equate this to 0, the value that we would get is only one value, which is x is equal to 25. So there is no other possible values. So therefore, pwede kita din makakonclude that our critical point is x is equal to 25. So I presented also here a graph of or the representation of the equations we have. So maximum area is 1,250 square feet when x is equal to 25 feet. Then we have y is equal to 100 minus 2x. So 100 minus 2 times 25 is equal to 50. So to maximize the area, so we have the sides nga 50 by 25. So multiplying that one, we have 100 to 50, 1,250 feet. Okay, so this is the problem that was said to be presented a while ago. So we have an open top box is to be made from 24-inch by 36-inch piece of cardboard by removing a square from each corner of the box and folding up the flaps on each side. What size square should be cut out of each corner to get the box to the maximum value? Probably medyo hindi naton ma-visualize ang inyong problem. So, you have a certain value of a cardboard or certain dimension. Makuha ka sang squares, tanan nga corner, pilon mo siya in order for you to form a box. So, ginapamangkot sa aton, ano ang size ng square nga iguntingon para maximum ang aton nga volume. Okay, so to illustrate this one, we have the representation here. So, makuha ka sang value sang square diri sa imong mga corners in order for us to have a maximum volume sa aton nga box. So, let x be the side of the square to be removed from each corner, then the remaining four flaps can be folded up to form an open top box. Let v be the volume of the resulting box. So, for the next step, we are trying to maximize the volume of the box. Therefore, the problem is to maximize the V or the volume on our specific equation. So as mentioned in step 2, we are trying to maximize the volume of the box. So the volume of the box is V is equal to L times W times H, wherein the volume is based on the knowledge about geometry. Volume is equal to the length times width times height, where L, W, and H represents length, width, and height respectively. So from this one, we have to see that the height of the box is x inches. The length is, so we have, so ang length natin will be, so 36 ang kabilugan nga length, minus santas ang duwa ka x, so we have 36 minus 2x. And the width is 24 buhinan tas ang 2x. So, ang aton nga volume of the box natin will be, so we have, so length times width times height, so we have 36 minus 2x, 24 minus 2x, then ang height natin will be x. Then, in order to find the volume, we are going to multiply sa tatlo ka parameters. Length times width times height, we will have the equation 4x cubed minus 120x squared plus 864x. So, to determine the domain of the consideration, let's examine the figure. Certainly, we need nga dapat ang ating values ng x should be greater than 0. Hindi man pwede nga ang aton values, ang height sa aton nga box is negative. So, dapat positive gid. That means greater than 0. Furthermore, the side length of the square cannot be greater than or equal to half the length of the shorter side. So, ano ang matabo if ang aton nga x, for example, is twice ang half sini. So, both silingon, kung ang x to be, for example, 12, anong matabo? So, that means nga 24 minus 2 times 12, for example, so 0 na ni karon aton side. So, that means hindi pwede nga ang aton nga value of the shorter side will be 12. Or ang aton nga x, I mean, will be 12. So, hindi pwede. Otherwise, one of the flaps would be completely cut off. So, since ang aton nga v of x is continuous function over a closed nga graph, so v must have an absolute maximum and an absolute minimum. Since may ara siya sa graph, kay may ara kita equation, so we have 4x cubed minus 120x squared plus 864x. That means may ara siya nga maximum value and may ara siya minimum value. And we are going to find that one or the critical points of the graph by differentiating or by finding the derivative of the equation. So let's derive the equation. Derivative of 4x cubed will be 12x squared. Derivative of your negative 120x squared will be negative 240x. Then the derivative of 864x is equal to 864. So to find the critical points, we need to solve the equation. So 12 will be common sa aton nga tanan nga term. So, okay, so we are going to equate this to 0 and simplify the equation if possible. So we have, based sa sini nga equation, pwede natin siya i-divide by 12, where ang aton nga equation will be x squared minus 20x plus 72 is equal to 0. Using the any mathematical nga process in order to find the value of x, pwede ka gagamit any possible nga process. But the best way to solve this one is through the quadratic formula. Kaya medyo mabudayan kita kung factoring pa. So we are going to use the quadratic formula, wherein if you perform quadratic formula, you will arrive to the answer, which is 10 plus minus 2 square root of 7. So, since may ara kita duha ka possible value of the answer, we have 10 plus 2 square root of 7 or 10 minus 2 square root of 7. So, inspect natin answer. So, ang 10 plus 2 square root of 7, so if lantawon nimo, ang value sini will be greater than 12. So, both siningon, based ka gina sa constraint nga ginhambal naton, hindi kita pwede makalapaw sa 12. So, hindi pwede makalapaw sa 12. So, that means yung ini nga value is not possible or it should not be considered as one of your solution to sini nga problem. So, isa na lang nabilin sa aton which is 10 minus 2 square root of 7. Therefore, the volume is maximized if we let x is equal to 10 minus 2 square root of 7 inches. Then, dara natin dayon isolve ang aton maximum volume. Maximum volume will be, so we have 640 plus 448 square root of 7 or 18,000 or 1,825 inch cube. So, ang ari, so was solved gamit sa mga values ang length, width, kag height. So, substitute mo lang di ang x mga value. So, para makuha mo ang individual nga values. Then, solve mo na dayon length times width times height. So, we have also the graph. So, kung makita ninyo, amo ni ang possible nga graph sa aton nga equation sa sini nga specific nga problem. So, I also have here a somewhat simple kung lang tawon naton but a tricky problem. So, this is a problem nga probably gakakita na naton or gaka experience naton sa mga or gakakita naton sa mga social media nga gina-present kung diin ang or anong pinaka lapit nga way or anong area or paano kita makalambot sa specific nga lugar nga in a shortest possible time o kung minimize naton ang time nga pwede himuon. So we have an island is 2 miles due north of its closest point along a straight shoreline. A visitor is staying at a cabin on the shore that is 6 miles west of that point. The visitor is planning to go from the cabin to the island. Suppose the visitor runs at a rate of 8 miles per hour and swims at the rate of 3 miles per hour. How far should the visitor run before swimming to minimize the time it takes to reach the island? So medyo complicated ang problem. So this one I presented and shows this type of problem in order for you to um, see nga may ara kita ginaplastar nga medyo complicated nga mga problems in order to for you to base man sa inyo nga experience diri sa basic calculus and for your references sa inyong mga activities. Okay, so in order to illustrate that one, we have represented or presented or illustrated an example or an illustration here. So we have your cabin and we have an island. So we have this one. So naka-plus-star man kagina, we have 6 miles. So we let sang area nga iya nga dalaganan as x miles. So ang nabili na dayon will be 6 minus x. So kabalo kita nga ang vertical distance is 2 miles. So ari ang value ilet naton as y. So diri siya ma-shortcut pakadto sa aton island. So ang pangitaon naton nga value is x kag y. So let x be the distance running and let y be the distance swimming. Let b be the time it takes to get from the cabin to the island. So take note nga we are considering ari gidi siya sa kilid. Ha? So nga madiretso na lang siya dayon lang may. So the problem is to minimize the time naton or time nga gamiton naton. So to find the time spent from the cabin to the island, add the time spent running and the time spent swimming. So take note, based on your sciences nga subject, the distance is equals to your rate multiplied by the time. So ang time naton for nga i-consider para sa dalagan or sa running will be equal to the distance nga idalagano niya divided by sa iyang rate. So that is, distance nga ma-run siya is x divided by 8 ang iyang rate or iyang speed. And the time nga ma-spend niya for swimming will be distance nga i-spend niya for swimming or nga iyang agyan kung mag-swim siya and then ang rate niya mag-swim. So that is 3 miles per hour. Therefore, kung i-add naton, we will have ang total nga time will be equal to x all over 8 plus y all over 3. So medyo daw hapos lang ng tawon because we are adding just the uh, rate dere. But medyo ang tricky dere nga part is for the sa aton na nga next nga mga steps. Okay, from the line segment of y miles forms the hypotenuse of a right triangle. So, take note that based on the steps we presented, dapat naton i-plus star ang aton nga answer in one variable na lang. So, that's why we need to substitute value for y, dapat x na lang aton variable. So, the y miles forms the hypotenuse of a right triangle with legs of length 2 miles and 6 minus x miles. So kung tanong mo natin, diri sa ating triangle nga na-form, we have 2 miles, we have 6 minus x miles, and we have y miles. So since right triangle siya, we can apply the Pythagorean theorem, which is equal to 2 squared plus 6 minus x squared is equal to y squared. And we obtain sa aton nga equation which is square root of 6 minus x squared plus 4. Thus, the total time spent traveling is given by the function. So, substitute na siya. We will have this equation. Okay, from the figure, we see that aton nga value, dapat sa aton nga x should be between lang sang 0 pakato sa 6. Therefore, ang aton nga domain is 0 to 6. So, amo na ang aton nga, lang dapat ma-run ang imong answer sang values ng x. Since ang aton nga i-maximize is ang equation natin nga t of x, which is continuous function over a closed bounded interval, so mayara siya maximum kag mayara siya minimum. Since mayara kita equation, mayara siya maximum, mayara siya minimum. Let's begin by looking for any critical points of t over the interval 0 to 6. So kinahanglan natin pangitawan ang ating critical points. That means we need to derive. So derive natin ang kabilugan ng equation, derivative of x over 8. So that is equal to 1 all over 8. Then this time, derive natin ang aring equation. Sir, paano na siya i-derive? So, hindi ko na ipag-detalye because we were able to discuss this on the previous discussion about derivatives. But this is the application of your chain rule nga topic. So, we have, exponent natin diri is 1/2. So, papanawag ko ang 1/2. We have 1/2. Copy ko ang bilog ng equation which is 6 minus x squared plus 4 negative 1/2. So, copy ko lang man ang 3 kay constant naman siya. Then, multiply natin siya by the derivatives ng aton nga inner function. Inner function natin will be 2. So, multiplied ang 2 multiplied by 6 minus x. Then, derivatives ng x is equal to 1 lang man. So, this time, amo na yung aton nga equation applying the chain rule natin. So, we have, simplify natin ang equation. This will be equal to 1 all over 8 minus 6 minus x all over, 6 minus x, adding a 6 minus x. So, we have, makancel lang man ang aton nga 2 dere, ang mabilin is 3 na lang. Then, ang aring negative 1/2, dapat mapapanaog siya kay negative ang i-exponent. So, be equal to, copy ito na lang bilog na equation. So, that's it para sa aton nga process. Then, we are going to equate sa aton nga answer into 0. So, if we equate sa aton answer into 0, pwede na itong sailuhon ang aton nga 1 all over 8 sa piyak. So, we will have this equation na dayon. So, in order to manipulate this equation nga mas hapos sa aton, we are going to cross multiply. So, we'll have 3 square root of 6 minus x squared plus 4 is equal to 8 times 6 minus x. So, if we square both sides of the equation, we see that if x satisfies this equation, then x must satisfy sang aring equation. So, this is square natin both sides of the equation. So, we have 9. So, 9 na lang ni. Square naman yung square root. So, madula ang square root. So, mabili na muna lang ni. Square tang 8, that will be 64. Square tang 6 minus x squared, that is equal to squared. So, ginhimo natin ang squaring of both sides of the equation para madula natin or ma-eliminate natin ang square root nga symbol or radical symbol natin. So, we have, So this becomes, so since pareho sila 6 minus x squared, pwede natin sila i-combine. So we have 9. So 64 minus 9, that is equal to 55 times 6 minus x squared. Then 9 times 4 will be equal to 36. So amo na dahil natin nga equation. So we conclude that if x is a critical point, then x satisfies ang sininga equation. So x minus 6 squared is equal to 36 all over 55. So, okay, so let's proceed. Therefore, the possibilities for critical points are, so your x could be, kung isolve natin, we would arrive sa values ng x, which is 6 plus minus 6 all over square root of 5. So, amo niyang possible nga values ang aton nga 6, same nga prinsipyo kagina. So, hindi pwede maglapaw sa 6 ang aton nga answer. So, hindi ni pwede. So, this one lang aton nga only nga critical point. So, if we substitute this aton nga answer, we will have the answer. So, hindi ta na pag-i-detalye again, but you can solve on your own. So, since this is just a supplementary video, we will have t is equal to 1.368 nga hour. So, therefore, we conclude that T has a local minimum at x is equal to 5.19 miles. Okay, so we will have another example. A rectangular box with a square base, an open top, and a volume of 216-inch cube is to be constructed. What should be the dimensions of the box to be minimized, or to the box to minimize the surface area of the box? So what is the minimum surface area? This time, kabalo ka sang volume, din pa pangmangkot sa imo ano ang dimensions ng box. Then, ano ang iyang surface area. So, we represent the box through this one open na sa babaw. Draw the rectangular box and introduce the variable x to represent the length of each side of the square base. So, square na ang base natin is x. So, parehas lang sila kay square man. So, to represent the height, gamito natin is y. Then S to denote sa ating surface area. So we need to minimize the surface area. Therefore, we need to minimize S. So ano ang surface area? So surface area is, kung ilantaw natin, that is, ang tanan-tanan nga area nga makita nimo. So area sang sining mga sides, then area sang sa dalom nga part. Since wala cover sa babaw, so isa lang sa dalom nga ito ni-consider kang apat ka side. So that means pila niya ang area sang ari sang sa side. So that is 4x times y. So that's why we have x times y. And then sa dalom nga side, x times x, that is equal to x squared. Since the volume of this box is, so ang volume niya is length times width times height. So that is x times y. That is equal to x squared y. And the volume is given by 216-inch cube. So, kabalo kita sa sininga value. So, we have, that is our constraint, x squared y is equal to 216. Okay, so continuing sa aton nga solution, solving sa constraint natin, we will have y natin will be equal to 216 all over x squared. Therefore, we can write the surface area as a function of x only. So, substitute kita sa values ng y, so we have 4x times 216 over x squared plus x squared. And then, we will have, so makansel kita isa ka values ng x dere or isa ka x, so we have 864 all over x plus x squared. Since we are requiring that x squared y is equal to 216, we cannot have x nga 0. So, syempre, hindi pwede nga 0 ang aton nga x. So, both silingon x naton dapat is greater than 0. On other hand, x is allowed to have any positive value. Note that as x becomes large, mataas man ang value sang height sang aton nga box. So, I mean, that if magtaas ang value sang x, so, ang y naton nubo. So that, ang aton nga x squared y will be equal to 216. Similarly, kung maggamay naman, ang aton nga value sang x, mataas ang aton nga value sang height. So, we have to consider that constraints nga gipresent sa aton nga problem. Since Ang ato nga surface area represented by S is continuous, dapat mayara siya absolute minimum kag maximum. So, paano natin gani mahambang ang minimum siya or maximum? Especially if that is presented in a polynomial form. Since naka-polynomial form siya, but silingin continuous siya. So, we are going to find the critical points so dapat ma-derive kita. Derivative natin will be equal to, so, negative 864x squared, ang muna niya itong derivative, plus 2x. So we have, kung i-factor din nato ang aring equation, we will come up with the idea nga ang aton nga, if we equate, so we will come up with the concept nga muna ning mabilin sa aton equation. 2x is equal to 864x squared kung i-equate siya sa 0. Solving this equation for x, ma-obtain naton nga, so multiply naton ang x squared dito, we'll have 2x cubed. So, mahimo x cubed is equal to 864. So, ang aton din nga x will be equal to cube root of 432, which is equal to 6 times cube root of 2. So, naka-express lang siya in radical form kay para insakto gid ang atong answer. Since this is the only critical point, so wala na iban nga value nga pwede mo ka with this one. So, this is the critical point sa aton nga equation S. So, the absolute minimum must occur at this value. So, aton absolute minimum is 6 cube root of 2. Ang y naton dayon will be this one, 3 cube root of 2 inches. So therefore, pwede na natin makuha dayon ang aton nga so kabalo na kita sang x kag y, this will be aton nga dimensions. So ang aton nga surface area will be solve naton, balik naton sa original equation, will be 108 cube root of 4 inch squared. So we have presented sari-sari nga type of problems para sa inyong reference. So what are the summary or the key concepts in the discussion we have? So this are the following nga gin-enumerate ko. So to solve an optimization problem, begin by drawing a picture and introducing the variables. Next, kung may ara ka na drawing, find an equation relating the variables. Go back to the ideas nga kag concept nga natun-an nimo sa previous nga subject. This is important. Algebra, trigonometry, sciences subjects. So, importante na siya for this study of or for this solving sang mga equations diri sa calculus. Next, find an equation relating the variable. So, amo na ginahambal naton, kinahanglan mo balikan and then maobra ka equation. So, you should be knowledgeable of different ng mga approach in a problem. Find a function of one variable to describe the quantity that is to be minimized or maximized. So, pag ubra mo sang specific nga problem, relate those equations. So, may makita ka na da nga mga specific nga parameters nga pwede nimo ma-relate. Then, reduce mo na siya dapat into one variable. Either x na lang makita nimo or y na lang or any variable, for example, nga pwede nimo i-represent. Then, after sina, look for the critical points to locate your local extrema or minima. So, dapat pangitawan mo dayon ng mga critical points. So, as what was discussed kagina, if you are trying to find the critical points, you need to perform the derivative naton. So, i-derive mo siya, then equate to 0. That is where you will find the value of your critical point. And then, if nakakita ka na critical point, kung isa lang value of your critical point, that is automatically be the critical point nimo. And that will be the answer for that specific na problem. But, if damo, possible nga values, especially kung pag-derive nimo, you have duwa ka or tatlo ka values, you are going to inspect. Go back to the constraints nga gin-establish mo kagina and then compare and analyze kung din diri ang makahatag sang maximum or minimum value sa aton nga equation. So this is it for now. I do hope this would help or this will guide you with your activities and your